Good morning. I'm Daryl Brugink, Executive Editor with No-Till Farmer, and I'd like to welcome you to this morning's webinar where we are going to learn a bit about some basics on how you might capture nutrients with cover crops. Today's No-Till Farmer webinar is sponsored by Cover Crop Solutions. They are the producers of the tillage radish and many other cover crop seed offerings, including numerous blends of cover crop seed. We want to thank them for making today's webinar possible. We also want to thank our presenter, Dr. Tracy Blackmer, the Director of Research for Cover Crop Solutions, for sharing the latest on the species of cover crops available to scavenge or produce nutrients that can allow no-tillers to reduce their reliance on applied fertilizer. So with that said, I want to thank you again for joining us, and we're going to turn over the controls to Dr. Blackmer. Good morning, Dr. Blackmer, and thank you for leading today's webinar. Do we have you?
Well, thank you, and good morning, everyone. Well, this morning on the webinar, I would like to go over a number of things with the cover crops as it relates to the nutrient component in the cover crops in terms of catching and releasing nutrients. But I want to give a few other of the benefits that go along with it as well. But the primary focus will, in fact, be on the nutrients. Now, one of the things that cover crops is really well known for is a lot of the erosion control. I don't think anyone argues that or doesn't see the problem with those benefits. But I don't think we really talk about other benefits like the nutrient credit. Clearly we can help with the wind erosion and the water erosion, but we don't have estimates of how much of a nutrient credit we get from the typical cover crop. So as we go through and we look at the different benefits of cover crops, the erosion control is a big one. We can tie up nutrients. There's compaction alleviation, water quality, feed for livestock. But one of the key things to get those benefits is you have to plan to get that specific benefit. It's not something that if you just plant a cover crop, you automatically get all of those benefits. A lot of times there are different strategies and you won't get all of the benefits. You may get one or several of them. More recently, probably the biggest push, at least from the government side of things in cover crops, is actually in the water quality. The erosion control has been there for a long time, but as we look at programs like the Mississippi River Basin Initiative, where there's millions of dollars going in trying to reduce the nitrate loading into the Gulf of Mexico, this is followed by programs like in what's happened in Chesapeake Bay for quite a while that has put a lot of resources into cover crops. And there's been some degree up in the Great Lakes Basin as well. But the key focus as it relates to nutrient is the nitrate loading, for example, in the Gulf of Mexico. This map shows where there are more nutrients loaded in an area going down. So the darker red means there's more nitrogen leaving the field, goes down to the Gulf of Mexico. That's why we're seeing a lot of government money going into this. Now, if we're losing a lot of those nutrients and cover crops helps prevent those losses, that's actually credits of nutrients that we're holding in our field and comes back as a value to grower. And that's something we don't hear as much on. How do we estimate that value? How do we capture that value that we know is in fact there? One of the easiest ways to illustrate some of the losses, at least in a lot of the Midwest, and there's tile in a lot of places, is this picture of a tile line where you can see the water running through the tile line. You can see the creek. Eventually the creek goes to a river. Eventually rivers go down the Gulf of Mexico. You'll see there's no living crop in the field above that, yet the tile lines still run. When we get a leaching rain, nitrate moves freely with the water, and we've done a very good job of building an infrastructure to remove the water from the field. So if we can go in and actually keep a cover crop up on that field that will hold those nutrients, so when we get a leaching rain, it doesn't go down to the tile, that is in fact a mechanism that we can catch and hold those nutrients. If we look at an assessment of how much cover crops can help hold nutrients versus other BMPs, so to speak, this is a table showing the different management practices in Iowa. And this was put together by the science team at Iowa. and they were looking at nutrient reduction. And on the left side, you can see the first bar. It says if they were to plant rye, cereal rye, on all of the corn and soybean acres, they would expect almost a 30% reduction in nitrate loading. If they go to the next B&P, if you were to use the ISU recommended N rate, they would say that would reduce things almost 10%. And if you keep moving to the right, so we go all the way to the far right, if we used all the anhydrous from the fall to the spring, we'd see almost no impact comparatively. Nitrification inhibitors, only 1 or 2%. So when you look at the impact of reducing the nitrate losses, cover crops stand out way ahead, really, of any other nutrient practice in terms of still producing a healthy and profitable crop. This is a research showing, this is a slide showing research from a number of different studies. This was put together by Casper and others. And on the far right, you'll see the reduction in the nitrate leaching. That a lot of these studies, you're talking significant nitrate reductions, even up to 70–80% in different areas around the country. So this is one thing that research people actually agree on, that cover crops will reduce it. So I just want to keep hitting that point. We know if we're reducing the nitrate, we know we're holding those nutrients. We know there's a potential value there. So thinking of it more from the grower perspective, well, I think every grower is an environmentalist to a degree. They also have to be a capitalist because they're running a business. So when I look at that tile line and I know that that water is running above 10 part per million nitrate in, I know that that's money that's leaving the field. When I'm buying fertilizer, that's money we're losing. Just to give you an idea, 10 part per million is the safe drinking water level. 30 part per million is, we have 1 acre foot of water. It's the same as about 80 pounds of N per acre. So when we look at the amount of water leaving some of these fields in concentrations, it can be a very sizable amount. So the catch crop for the different cover crops is if we can hold nutrients, so we have a plant growing further in the fall or even in the spring, and that plant is taking up nutrients, holding it in the plant tissue. It's in the leaves, it's in the roots, and if they have tubers, it's in the tubers. Things like nitrate and sulfate move freely with water. There's no product that will hold it in place. I mean, if you have it in the nitrate form or sulfate form and rains occur, that is lost. Other nutrients such as phosphorus or potassium, they're not going to really move with water. They're going to be there, so we aren't necessarily holding nutrients that would be lost, but we are putting them in a form that can be more available to the crop. Most soils have thousands and thousands of pounds of P and K, but it has a very small fraction of it that's available to a crop. So by having something else growing that can tolerate more of the off-season from another crop, allows us to concentrate those nutrients and put it into a better form for the next crop to use. Now usually the first thing that comes in my area, I don't have enough of a growing window. And that's pretty much anywhere we are. Even people in Florida have made this claim. And I want to point out that if we think of it from something fairly simple as corn and soybeans, I mean, obviously following wheat, if you're not double cropping, that's a pretty easy system. But when we look at things like the Midwest, this is a map I pulled from one of the seed guides just showing the different maturity of corn planted throughout the Midwest. From that, you'll see that as you go further north, the maturities change. So I live in central Iowa, and I was at a meeting up in northern Minnesota, and they were saying they don't have the time window up there. And I would agree if they were planting the same 110-day corn we plant down in my area, if they're planting up there, but they're planting 80-day corn. So the net effect is that time window is actually pretty similar because people are adjusting their crops on there. That doesn't mean it's easy. That doesn't mean you have a long window. But it does mean that people tend to adapt their crops to their conditions in the area. So some crop rotations are definitely more easy than others. Well, if you want the benefit of a cover crop, you've got to get the cover crop to grow. How do you do that? Well, things like drills are very good in the sense that it puts it in the ground, so you're getting a better seed soil contact and will grow. But the challenge is a lot of time that crop isn't off real early to give you a full window of growth. So that's one way. Being prepared is important. Things like precision planting. A lot of people now are getting the plates, they're getting planters, they can put it more uniform. If you put it out more uniform, you're actually getting, you can use lower seed values, I mean seed population counts, you can lower your seeding costs that way. And that's important because you have to have a good crop set up to be able to catch those nutrients. We look at things like using mixtures, and we'll explain more why in terms of why using mixtures of cover crop makes sense from a nutrient perspective, but that may take certain planters, in this case for precision planting, if you use a Kinsey brush meter, that will help you use the mixtures as compared to some that may be more conducive to similar size seed. We can put seeding out while we're harvesting. This is a picture of a Gandy seeder, and what this is doing is that as we are going through the field at harvest time, you're actually spreading the seed under the spout on the header, and that is allowing the seed to hit the ground before the corn residue in the back of the combine hits the ground. So you've already seeded it, it's getting good soil contact. It's another way of getting in earlier, getting that earlier establishment. And again, I'm saying this because a lot of people think the nutrient value won't pertain because they can't seed it. I'm trying to demonstrate there's a number of methods. This is aerial seeding in the field, and there's both planes and helicopters that will let you go into standing crops. We've seen a big increase in people using this. There's benefits to doing this. It's easy. You can order it. Some of the some of the cons on it is not all areas are conducive to this, as we see more windmills and power lines, depending on the type of equipment you have. It's also, some of the seed can get caught in like the corn canopy. It's also on top of the ground, which if it's dry can be a problem. For things like soybeans, getting it into that canopy is very important timing so that you aren't too early to have the seeds blocked out so it doesn't get sunlight to grow. We're seeing more interest from a lot of the equipment companies, especially making. This is Hagie with one of their high clearance seeders. You can see where the seed is going into the canopy, it's dropping down through the leaves, and then it's actually hitting the place and dispersing under the canopy. We're seeing a lot of different growers adapting their own equipment, finding ways that they can go out into the field. So some people are taking the high clearance sprayers, they're actually putting tubes on, so again, dropping it down in the canopy so there's not as much cat in the leaves and just kind of spreading it on the ground. There's also interest in trying to say, okay, can we actually not go in so much towards the end of the season, but can we actually establish the crop a little bit earlier? So can we go in really as kind of a late planting, or what a lot of people are referring to as interseeding? And this is a picture of a prototype from Penn State showing where they're going in and seeding the crop while it's standing so that you can get a good germination and stand, and then as the season grows it's fairly dormant, but then when you take the crop off it's got a big head start and ready to grow. Now, a lot of people ask, okay, what species work on that? I put a few that we've seen probably the most benefit so far. This is still very dependent on where you are. Things like annual ryegrass, crimson clover, and radishes, there's been success in doing this. And if done correctly, in some areas like Pennsylvania, they've actually had some pretty good positive yield things. So my point in showing this is that there are ways we can get a cover crop growing early enough to actually catch or take up significant nutrients. Probably the easiest way to widen that window to go in is with shorter season genetics. Most people plan a range of maturities in their genetics anyway. So if you plan your cover crops matching up with the earlier ones, That can make a big difference in the heat units or growing conditions you have for a cover crop. And this is something that I think most people have shorter maturity. They don't necessarily tie it in. I think as people document the value, we're going to see more and more of that consideration and testing of how do we get more of this short season genetics in the mix where we're trying to get an adequate stand for cover crops. Okay, so as we're talking about getting established timely, there's another important part for catching the nutrient values, and that's you've got to have the fertility there in order for a crop to grow. So this is a picture, an aerial image of a field on the left, and the red streaks through the field are strips of cereal rye. So this was planted around the 1st of November. And I have a red arrow on there saying the edge of application, because this is a field where they put a waste product out. They didn't think nitrogen in it. But on the left side, they actually had a farmstead, and they tried to avoid the well for putting out the waste product. So the arrow's pointing to the edge of a mark where they stopped applying, and you can see where it's more red. That means there's more vegetative growth. You're seeing the difference in growth just because of essentially the nutrients that were put in the waste product. On the right is showing that picture where you can see the line right up to where they stopped applying the nutrients, how it's a lot less growth, more yellow in the front of the picture, and as you go back it's darker green. That's important. If we're expecting to have significant growth, we have to have the nutrients there to have that growth to be able to get the benefit in terms of tying that up. Now if we look on the extreme end of things, just how much can we really tie up? I'm going to go to one of the prevented planting fields that we had last year. And last year in the Midwest, there were areas that had so much rain they never really got a corn crop in. So they went and they put cover crops in pretty timely, earlier than you normally would. And I'm going to show this example was planted around the 1st of August. This was a cornfield. It had about 60 pounds of nitrogen put on pre-plant with the anticipation of planting corn. This was a field. You get good yields, high organic matter. The grower dissed it to keep the weeds down, actually went in and used a roller to put the seed in the ground and got a very good seed, and you're looking at the canopy of this field. So this is in central Iowa last year. And so when we look at how much nutrients were taken up and then released, the first step is how much was taken up. So we went into this field in the canopy and we put down a 3-foot by 6-foot ring so that we could take all of the plant material in there. So we took the leaves off the top, and then we took the tubers off as the bottom as 2 separate samples, and we sent it into a lab. And we did that for multiple parts in the field. So this is a picture showing the actual tubers in the field, and you can see a tape measure out there. The soil line is about 12 inches, and you'll see again another 4 to 6 inches above the soil line, and that's normal for these. These are the tillage radish. But when we look at the nutrient content in that, I just want you to think in your own mind, how many pounds of N, P, K, different nutrients are taken up from that? Because that gives us a starting point to estimate what would be released the next year. If we know it was taken up, we know what's there. Therefore, that's a starting point on that. And I think that's something we haven't seen a lot of cover crop research really do, is to talk about the uptake and estimate. So if you're a grower growing cover crops already, or you're planning to take a few samples just to see what was taken up, I think would be a really good idea as a starting point to estimate the nutrient availability to you. So this is a graph, I just put it up, where we are looking at some of the key nutrients that were taken up. And this is an average of 3 different parts in that prevented planting field. Again, I want to emphasize this is prevented planting, so this is the very high end. Most people won't have that long a growing season to do this. But the first set of bars, the green bars, beef tissue. The whitish bar is the tuber, and then the red is the 2 combined. So if we look at the total nitrogen uptake, and this is pounds of N per acre, we're looking at over 360 pounds of N were taken up. Now again, that was a prevented planting field. It had some fertilizer on it, so this is the extreme end. but at least it gives some idea of on the high end. I mean, if you have a field you don't plant for whatever reason, can you tie up nutrients? Can you catch them and have them available for the next crop? And this would say yes. This would tie up a tremendous amount. If we look at the P, it's actually pretty low in P. There was about 60 pounds taken up. There's about 550 pounds of potash, which is a huge amount. There's also quite a bit of sulfur taken up in these as well. So I think this is a starting point. If you want to know what will be released to your field, you have to know at least what was taken up. In this case, things like the radishes, it's easy to get both above and below ground. So if we look at it from an economic perspective and we say, how much value is there? Well, if we had 364 pounds of N, I know the spring co-op near me was 58 cents a pound. That's over $200 in nitrogen that's tied up in that radish. Now, that doesn't mean it'll all be available the next year. Let's say it was half. That's still $100 just for nitrogen alone, let alone any other benefit the cover crop may have. Of course, the flip side of that is if this was your field and you didn't have a history with cover crops, if you cut that in half, that's 180 pounds of N. That's about what the grower would usually put out. It's a little bit more. How comfortable would you be applying no nitrogen? I think this grower was kind of nervous, but actually ended up not putting any down, just kind of watching to see if he'll put more down. But that's a huge value in there. Now, the P and the K that's in there, that's not P or K we would have lost. So it's not like the nitrogen where we could have a significant loss in that nitrogen. The P and K is actually something that might make it more available. But I get a little nervous when I hear people say, if you plant cover crops, you don't need any fertilizer, because I don't believe that. But I do believe that it can help make some of it more available for a while, but eventually we are mining the soil, we'll have to put some back. But some soils have an awful lot. I think it certainly would help make it more available, almost like a starter effect in a lot of these. Well, if we look at the fourth column, and I didn't put a dollar value on this because I don't know how to estimate the cost of sulfur. There's so many different forms, and it depends on the system you're putting into it. But I think it's a real important point because there's over 100 pounds of sulfur that were taken up in this, in the radishes. Now, the radishes are a little different in the sense that they're very high in sulfur. They're the ones that really have a lot of the glucosinolates. And so if you hear about some of the smell sometimes with the radishes when they break down, it's because of that, basically the glucosinolates, the smell in that. But there's some benefit to that. And if we look at crop removal of sulfur, I know that's not as common in some parts of the country where they're deficient. But 180 bushel of corn, for example, would have a crop removal of about 15 pounds of sulfur per acre. So we are really taking up a lot of that sulfur. So again, the plant's slowly accumulating it. And again, it has some pretty deep roots, so it's pulling it out perhaps better than some crops would. And it's concentrating it so it's available the next spring. Well, that is actually some of the benefits they've seen in the mid-Atlantic area is actually the sulfur available. Now, this is pictures in Iowa, but we're seeing more and more sulfur deficiencies in places as we have cleaned up the air. So the picture that just came up is showing stripes in the leaves on the left, which is a sulfur deficiency, and on the right is showing a healthy crop. Well, if we can have our cover crops that are helping to make that sulfate available to the crop early in the season, check the low organic matter soils where we tend to see more of it, that's an early benefit to that crop to help get it, and that's been part of the yield increase benefits they've seen with the radishes over the years. Now, people may argue common is the sulfur deficiencies, and I think it obviously depends a lot on where you are, whether you're fertilizing and removing, but in general we are removing more with our crops than what the rainfall is naturally putting back. Just to show the prevalence, this is taken out of my backyard. It's showing the neighbor's field to the immediately beside me, and you can see the corn rows, you can see the straight direction of corn rows, and then you can see the angle of the application on the right going off to an angle. So that angle to the rows was actually where an anhydrous applicator drove through the field, and you're seeing the darker green is where the roots have found that anhydrous knife. It was fall applied anhydrous ammonia. But when you actually go out to look at the yellow and say, okay, what was that color? At first I just assumed it was nitrogen. But when I actually walked out in the field, on the left you can see the streaks in the corn where it was more yellow, and then where it was more green from those streaks you can see that there was no streaks in it, meaning sulfur. All of the fields that I scouted that had radishes in them this year, none of them showed this effect. So that's not side-by-side comparisons or whatever, but I think it's helping to show that if we can use the cover crops to tie up the nutrients, especially in that early state when the roots aren't as developed to reach out, we have a lot of leaching usually going in the spring in most areas of the country, the cover crop can really help provide some benefit in doing that. Now, if we talk about more of what I would say a normal time frame is for a corn and soybean system, these are showing pictures of things that were planted. Again, this is central Iowa, where they planted them on September 11th. And there's 2 rows of radishes. And the radishes on the top are showing about a 30-pound of N per acre concentration. So when you go out and measure a 3 by 6 foot area, and we take the plants out, we're looking at both the tuber and the tissue from radishes, we're seeing about 30 pounds of N per acre. So this is following a corn or a soybean system when we're getting in on the earlier end of those harvests. This is probably a more realistic expectation of what a nutrient tie-up would be. So again, if we talk about this is what we're catching, that's a starting point to say what might be available the next year. If we look at the bottom row, this was planted the same time, but it was more limited fertility. You're only seeing about 5 pounds of N per acre. So to get a little bit of a gauge when you look at the radishes, this helps talk about, at least from a nitrogen capture point of view, what it is you can look for to help calibrate. And again, I can't emphasize enough, I think people to take a few of these samples themselves in their own field is an excellent way to start trying to get a gauge on that. Well, if we look at several of the cover crops, and these were all replicated plots, there's 4 reps and small plots, they're 40 by 40 feet. We put 2 treatments in. Because you have to have fertility to grow, we deliberately picked a spot that had been cropped down for nitrogen. The other fertility was adequate, but it was deficient for nitrogen. And the blue is showing where we were depleted, and we applied 100 pounds was where the gold bars are. The gold bar showing 100 pounds. The tillage radish took up only about 5 pounds when we were depleted, but when we had over 100 pounds added, we showed we were taking up over 30 pounds of N. Now that's both above and below ground. If we look at the cereal rye, we're looking at just above ground. We can see it took closer to 15 pounds up, and when we added more fertility, we were pushing up closer to 25. The Bristol is a mix of ryegrass and radishes, so it has the tubers from the radishes, but it does not have the roots from the ryegrass. So you can argue there's more there below ground. We just couldn't easily measure it. But you can see when we added fertilizer, we had a lot more growth, which is important on what you can expect. If your field is really depleted and there's not a lot of nutrients there, you're not going to get the growth. You're not going to get the credit. Sometimes people ask, should we fertilize for it? Depends on how long your window. Depends on what you're looking for. For a lot of areas where they're putting down their phosphorus anyway, when what they're putting down in their MAP and their DAP could often be enough to really help get the crop by just on that level. So again, depending on what their expectations are. If we look at other nutrients in what's taken up, the same study, again, replicated study in central Iowa, we're looking at the nitrogen uptake, but then we're also, and this is a tillage radish here, so again we have that 5 pounds versus 30 pounds, but then we look at the other nutrients, the phosphorus, the potash, and the sulfur, and you notice where we added more nitrogen, and it was only nitrogen. This nitrogen really helped increase some of the other nutrients such as the phosphorus, potash, and sulfur. So it was kind of the weak link in the growing, but that can help tie up and help make the other nutrients available. Again, emphasizing the need that you have to have fertility for it to grow, and if you want it to release fertility or to have much of a credit, you've got to have that growth. Well, part of the problem in estimating how much nutrient is available is when the residue breaks down, how fast will it be readily available? Right now, the main credits you see for cover crops tend to be negative. And that's because a lot of times the warning is if you plant some of the cover crops that have a spring growth, so let's say you're planting something like a cereal rye or ryegrass, and you let it grow fairly long in the spring and then you terminate it, you can actually be tying up nutrients because you have a lot of carbon. You don't have as much nitrogen. So the net effect is it's actually taking nitrogen that's available in the soil and tying it up in the decomposition process so your crop can be short. So there's a number of guidelines saying you need to add fertilizer to your cover crop. There's very few guidelines for anything other than legume to say how much nutrient you think should be available. This graph shows the carbon to nitrogen ratios of different cover crops. And again, the carbon, the plant, or microorganisms, they need to eat that carbon as an energy source, but with it they need a certain amount of nitrogen too. So when we have plants that have a lot of carbon and low nitrogen, the microorganisms really are going to be delayed in eating that carbon until it can get enough of that nitrogen. So when we talk about ratios of carbon to nitrogen of 30 to 1 or higher, that is something that is not going to be readily available to plants, and it could be a while before the plants would have those nutrients released. Things below 10 to 1 is considered very quick release, so there'd be almost no delay. So in this bar graph, we're showing several of the cover crops on the left and 2 on the right. Basically, all of them on the left are showing the cover crops typically in the vegetative stage, really before it's blooming. The one exception is the hairy vetch there. It says the bud or bloom. But it's showing all of those are below a 20 to 1 ratio. So those nutrients are going to be broken down fairly quick comparatively. If we look at the 2 on the right, we're looking at cereal rye and annual ryegrass. So the cereal rye at the boot stage, the annual ryegrass when it's heading, you can see the carbon to nitrogen ratios are very high. And that is the thing that if you wait too long to terminate those crops as a cover crop, it will immobilize nitrogen. Not only will we not have it available, you can actually have less nutrients available. So using a mixture of cover crops, depending on how long you're going to let it grow, you can actually help time the release of the nutrients. And that's one of the big interests in having a lot of the mixtures in the cover crops. Okay, so why is that important? I think knowing if we can document how much we're taking up by taking a sample of the plant, if we know the seed-in ratio, so we're talking about when it's available, that's critical for the nutrient release of anything in the tissue, not just the nitrogen, but if the carbon to nitrogen, and usually it's even the sulfur, the carbon to nitrogen to sulfur ratio is critical. Well, I think that one of the areas that's probably the biggest potential when you talk about holding nutrients is a lot of the manure application. So more and more we're seeing contract or commercial applicators putting out manure in many areas. Obviously, the equipment is expensive. They'd like to use it as wide a window as they can. And particularly in areas like, I'll say, the Midwest, we have a lot of the hog manure applied in the fall. We have informal guidelines saying don't put anhydrous ammonia out till it's 50 degrees in the ground, so you don't have the conversion as fast. There's parts of a lot of this hog manure that will convert much quicker, and just because the equipment limitation, the holding capacities, and they don't want compaction in the spring, a lot of times manure goes earlier. A properly timed cover crop, if you can get a cover crop growing to catch the nutrients as you're putting them out, it would hold those things, so not only would you have the environmental benefit, but you would be holding more of those nutrients, and a lot of times it can help mitigate some of the potential compaction problems you'd have as well. Obviously that depends on the type of manure, how you apply it, where you are, when you're applying, your weather. That's perhaps one of the largest areas that we can see some of the benefit on. Well, one of the concerns I have the most is that there's a big expectation to see these huge cover crop fields. Because usually we see pictures of cover crops, radishes. This wouldn't be a talk about radishes if we didn't have a giant radish in the picture. So I put one in. This is my daughter holding a giant radish. The only thing is, that's not normal. That's not to be expected. Even if you have a long window of time, you would want to have a higher seeding population so you wouldn't get one. That's because the population failed in that part of the field. It was a prevented planting field that grew it. And I guess I cringe a little bit when I hear people wanting to have giant radish growing contests, because that kind of gives the wrong expectations of what to expect and what you're looking for in a field. It certainly will tie up a lot of nutrients. However, what we're really looking for is we are looking for growth that will either scavenge the nitrogen, so we're tying up what's there, or if we want more growth, we may have to add some fertilizer. This is more of a reasonable expectation. And this picture on the right is showing where there was not fertilizer added. On the left there was. But that is more of a realistic expectation for the nutrient tie-up, or growth of a cover crop. So I think it's critical we get those expectations made. And it's that difference in the expectations is why we hear recommendations anywhere from a -40 to over 200 pounds for nitrogen credits. So if I switch a little bit, talking about some of the other benefits related to this, managing things like soybean cyst nematode. The cover crops have other values besides tying up nutrient. If you are going to plant a cover crop early enough to get enough growth to tie up nutrients, at the same time, there's other things that you can help manage, such as the soybean cyst nematode. This is a map. I think there's a newer one that just came out that shows it's even more prevalent, but the bottom line is people growing soybeans know what this is in the U.S. And there's different stories and things going about cover crop and nematodes, and I think it's important to really emphasize a key difference with the soybean cyst nematode, and that is the word cyst. Now in this picture, you're seeing the roots at the very top, and these are all out of the SCN handbook. But you can see that there's a lot of root feeding on the roots, which ultimately lowers yield. Immediately under that, you're seeing a picture of a couple live nematodes. Okay, there's tons of data showing how different types of cover crop can affect different kinds of live nematodes. A lot of times these things are used to help in things like potatoes and sugar beets in the rotation, because partly whether it's a host or not, but some of these things will produce chemicals that will actually help kill live ones. But what's different about the soybean cyst nematode is that when you think of the word cyst, it's the protective case around the eggs. So below the picture of the two live nematodes that look like worms, there's a picture of an egg. And then immediately right of that, you're seeing the cyst, which holds hundreds of eggs. So that cyst acts as a barrier to protect those eggs, and those eggs are viable for up to 10 years. So that's why we just can't fumigate them, and that's why a lot of things, when we hear cover crops kills all nematodes, cover crops can really help affect live nematodes, but it's not going to penetrate those cysts, not in terms of as a fumigant. Even applying direct fumigants don't do that. So if we get into more specifics on the benefits of that, the nematode control strategies is really 4 different thoughts in terms of how the nematode researchers and cover crops are having an impact. First one is it a host crop or a non-host crop? Obviously, if you have something that's not a host crop, you're not expanding the problem. Second one is the biofumigants. So as I had mentioned, there's some chemicals, really, especially in the brassica tissue, a lot of the glucosinolates, as they decompose, it really can form a cyanide gas. So in Europe, where they're not using a lot of the nematicides, they'll actually plant some of the mustards or radish or things that have a lot of the glucosinolates, plow that into the ground, and because a lot of that tissue is the above ground tissue, and that's what will help control the nematodes, and it allows them to plant more frequently than if they had to have longer rotations. The third theory is the hatch and starve. And the idea on that is that you're actually planting a cover crop so that you will get the nematodes to hatch from the eggs, but then they're not a host crop, so they can't live. And if they hatch and can't survive, they often you're greatly reducing the pressure. And there's been quite a bit of greenhouse studies and other things kind of showing how the certain the chemicals will in fact do that for some of the cover crops. But it's kind of hard to prove which of the different mechanisms is or is not causing some of this. The fourth strategy is increasing the suppression. Just very generalized saying, if we are increasing the biological activity in the soil, some of these improvements can increase more of the predators of the bad nematodes, which ultimately can get value for that. That's a very hard thing to prove and to say is tailored to the system, but it is definitely one of the mechanisms they talk about how cover crops can in fact improve some of the nematodes. There is quite a bit of research showing cover crops will reduce the nematode concentrations in these fields. Well, if we look at real studies, there's studies in greenhouse studies, there's studies in the Mid-Atlantic, there's studies in Canada. But from the Midwest, one of the more interesting studies I saw the data on, and this is from Mike Plummer, who was with the University of Illinois. He still says this is still needs a lot more research, but it was 4 different studies. Each one of them replicated. It's over 2 years. So 4 different locations, and it's showing, like in the first column, where there's no cover crop, the SCN egg count was over 7,000, which would be considered very much a problem. If you look at what the egg count was where they had planted cereal rye or annual ryegrass, they had statistically reduced them. And this is in all 4 of the fields for both cereal rye and annual ryegrass. Again, there's a lot more research in other areas showing it for different crops, and I think we need to tailor it in our area. But given the problem with the resistance of the SCN to a lot of our genetic resistance now, this I think is going to be a big benefit and will help us as we are getting some of the nutrient credits, because we need significant growth. Just like we talk about a 50-degree rule for putting down fertilizer in the fall, the same thing is true with nematodes, that it has to be warm enough if they're going to actually get some of the benefit. I mean, they have to be warm enough if they're going to live and hatch and multiply. So we have to get those cover crops planted early enough so it's growing to get the chemicals to create that process. And if we have it early enough and we have the fertility, we can get a lot of cover crop to also get the nutrient credits from the cover crops. I'll also point out real quick, when we talk about the amount of growth, a lot of time people believe it's the actual tuber that's given us the benefit and some of the compaction. This is showing a fairly small radish and a very long taproot. It's actually that small taproot that's given us the value in those soils. Okay? So again, a lot of people might look at it and say, well, that won't win a giant radish contest. Well, it's still giving value to the grower. It's also capable of pulling up nutrient from lower levels. So if we think about those small roots and then going through layers that may not have let other crops, such as corn or soybeans or different crops we have, if we can go through some of the clay pans and other areas and create root channels, water moves through, roots will grow, we get the benefit. We can also look for nutrients in lower profile. And a lot of our soils, the subsoils, actually have quite a bit of nutrients in them if we can get the roots to grow down, get the water, and take up the nutrients to do that. At the same time, when we create those root channels, we're also having it so the next roots can follow. So there's been some cool studies, and this is a picture from one of the presentations I found, that on the left you can see where they planted a canola root. It's a brassica, and you're seeing the root channel left after the root died. It's an empty channel on the left. On the right, you're seeing the soybean root that actually grew in that channel and spread into those empty channels, and that's what allowed the growth. So we can reach down deeper to pull nutrients in if that is in fact our goal. If we look at, in general, the yield response, I always kind of cringe when people say they did or didn't see a yield response in a crop, because it doesn't say why. Everyone wants to know, if I want to buy a cover crop, will I get a yield increase? Well, you need to know, when was that cover crop planted? What were you doing? Were you trying to catch nutrients for that? Was it, did you get enough biomass to, hold the nutrients? Was it something that you had enough time and growth to go through a clay pan if that's what you're trying to do? A lot of the details of why you would expect a yield increase need to be factored into these studies. I point that out because one of the bigger problems I see when people are starting with the cover crops is they aren't thinking about all the mechanisms. They haven't perfected a system to get a yield increase. A lot of times it's just to get the cover crop out to get the ground cover for erosion. This is a photo of a field that was a strip trial that had strips running from left and right in that field where they had cereal rye and where they did not. It was planted in the fall. It was terminated in the spring. The only thing is, it was terminated late enough that it actually hurt the crop yield. They lost about 8 bushel, and those yellow streaks you're seeing across the field is actually where they were too late in terminating that cover crop. And that I think is a big problem, a common problem for people in the beginning phase. I mean, especially if you're going out and spraying Roundup to terminate a spring cover crop, those cooler conditions is very different than when you're out spraying your Roundup Ready beans. So learning how to do that is an important part of it. In this case, even though the cereal rye grew significantly and tied up nutrients that we would expect to be available later, it was terminated so late that it actually probably immobilized the nutrients, and that's probably why we lost the yield. So if we look at a number of trials, we contracted out with a number of trials in Iowa, the Soybean Association there. These were all replicated trials. We put in 4 mixes plus a control. And this is the average of the 3 that were done successfully. Again, we had a bad year weather-wise. But the ones that only had crops that winter killed, meaning you didn't have to kill them in the spring, so there's plenty of time for it to break down, we saw a 4.6 and a 5.2, so about a 5 bushel yield increase with things that winter killed. But where we put in the triticale to help, as part of the mixture, the triticale you need to terminate in the spring, and there's problems that it wasn't terminated timely. And again, I don't think it's as much the triticale, I don't think it's as much cereal rye or annual ryegrass. Just any of those, if they're not terminated timely, can have a negative impact. And we can see we did not see a yield increase. We actually turned around and reduced yields. So this is an important understanding of the nutrient, both the pro and the cons. And I think that's something that we need a lot more education on to do that better. So in summary, I just want to say, in terms of some of the benefits with the nutrients, no doubt cover crops can catch and release nutrients. No doubt about it. If it grows, the plant's doing it. We aren't removing the crop. It's there. It'll increase the availability of some of the nutrients. There's been plenty of studies talking about how it will take up a lot of the P and K and sulfur, and it's concentrating that for the next spring, as well as nitrogen. The difference of the rooting profile, depending on your situation, the roots can help move the nutrients through the soil profile. So especially if it's lower, it can help pull it up. So if you're concentrating it in a more shallow depth, or especially if you're putting the tumor or the leaves on top, that can make a big difference. And then by having the right balance of the carbon, the nitrogen, the sulfur ratio, you can really affect the time of the availability of those nutrients. So you can help hold it, and then if you can coincide, so it's not really in a form that the plants can't take up until they're ready to, you can avoid a lot of the loss on that. So with that, I think I've used up the time I had, and I think we're probably ready to switch over if there's any questions.
Yeah, thank you very much, Tracy. We do have some time for some questions, and you can feel free to type those in. Well, I've got several here. I want to start with just one general question for you, Tracy. Just in general terms, what different cover crops or species do you find that are either good scavengers of nutrients, and are there some that are actually good, can actually produce some for you and release them back to you?
Okay, there's different parts to the question. So essentially anything that grow will help scavenge. It's a matter of how much time you have for growth, how much growth, and how deep the roots. And so a lot of times when we're talking, especially to new people, it's what are your planting window options? So for example, some people may not feel comfortable having to go in and terminating a crop in the spring. So that means we need something that might winter kill if they're in an area where that's it. So that would affect, those things affect the conditions. Things like the radishes, the tillage radishes are really good at tying up nutrients. We recommend for a lot of people that we recommend a mixture of radishes and oats for something they can put out in the fall. We kind of call that the training wheels because it'll self-terminate. You don't have to worry in the spring. We found that to be an excellent scavenger on things. Things like ryegrass will reach down real deep as well. So those are the fall ones. The only problem is if you're not going to be able to plant it early enough in the fall for the growth, then you're looking at things that will have to grow more in the spring, so things that survive the winter and you'll terminate. That's when we suggest things more like some of the ryegrass or even some of the triticale. We think both the ryegrass and the triticale, as compared to a cereal rye, they won't explode quite as fast in the spring, so they're a little easier to control. They'll still tie up a lot of nutrients, but we find that to be pretty beneficial. Then the idea of fixing nutrients, there's a number of legumes that will fix nitrogen, but it really depends on if you have enough of a time to get adequate growth so that it'll actually fix. And that's the thing, depending on your system and how long. But certainly some of the things, if we think of like a crimson clover, that's something we can plant in the fall. It's pretty quick. It's different from red clover. In the long run, red clover tends to grow better when you're thinking about it for multiple years. But for a cover crop, I found crimson clover to be good. So that would be a few of the starting crops anyway.
Okay, good summary. Thank you. Appreciate that. Back earlier in the presentation, you had shown some results from a farm in Cambridge, Iowa. If that comes back to mind here, the trials that were done there. The question that came out of there was whether that farmer in that Cambridge, Iowa scenario left a check strip to compare their yields. And I think that was that a prevented planting situation, if I remember right? Did they come back after prevented planting?
It is a prevented planting. Yeah, it is a prevented planting situation, so there was no crop last year. But this year he actually has multiple rates out of fertilizer on there. His main field he put no fertilizer on this spring, but he does have different rates out, and he will be measuring the yield to see if he needed any, if there's any benefit from adding fertilizer.
So that's still
there's actually replicated check strips in there.
So that's yet to come. We'll find out here yet to come. So
we'll know this fall.
Okay. What as far as the size of radishes, what would you say is the size you'd like to see? The example here is, finger size, thumb size. What could you compare it to, I guess, as far as a kind of appropriate size you're looking for?
Well, it partly depends on what it is you're trying to achieve, but in general, more growth is better. So if you have a longer window, you would hopefully get a lot more growth. Mm-hmm. If you follow a corn and soybean system, typically you're talking about radishes that would be, the tuber would be a little bigger than a carrot. That's where a lot of what I would call the corn and soybean belt would look like. Mm-hmm. But if you're trying to scavenge nutrients, you might want to mix in, depending on the time of your window, getting in some oats just to help. The radishes will typically break down faster, and then the oats will help make sure they don't break down too fast in the spring.
Okay.
So it helps balance it. But so it just depends on your window as to what your expectations are.
Gotcha. Regarding nematodes, can cover crops, will they affect even beneficial nematodes? Have you anything there? I know you talked about some of those that can hurt you and the impact they can have, but will it also have an impact on beneficial nematodes?
Well, I'll be honest, I haven't seen the data to say that it will, but it certainly makes sense that it's very hard to affect only one part of a system and not another. But with all the reports that I've read so far from the Journal of Nematology, they they have not shown a negative impact in terms of on the crop yield. So depending on what you say adversely affecting other nematodes, if you aren't seeing in response to the crop, I'd say I haven't seen anything documenting that.
Okay.
But it's a biological system, and it's hard to say exactly who is affected or who is not in the population.
Okay.
From a crop response, we have not seen negative effects that way.
Okay. Have you guys done any work with radishes in an interseeding scenario, such as with a corn crop?
Yes, we have done that, and actually one of the slides that I showed with several of the crops was the radishes in there, and they found that to be one of the better crops. From what I understand, when they start them off, they'll go pretty dormant, and they will grow later on, but you won't see nearly the size of the tumor. The tuber is more of a smaller because they're dormant, and then when they grow, just the pattern's a little different, so it's more roots than tubers on it. But they seem to be one of the better options than, say, the small grains, such as things like cereal rye or oats or things in terms of interseeding.
Okay. Okay. You had shown an Iowa State study that showed some corn yield loss with overwintering cover crops, if you recall which one that was. Do you happen to know what the tillage system was that they were working with in that study? That was another question that was raised.
Okay, there was actually one from the Iowa Soybean Association, not Iowa
That,
State University, that
that's it.
showed the
I'm
yield
sorry.
loss.
I'm sorry. That's right.
I do not know on hand, but yeah, okay, but if you actually go on to the Iowa Soybean Association's on-farm network, you can actually see all of their cover crop trials, and the type of data is listed with each trial. But I will also add that when you look at the summary of the actual Iowa State University or the USDA ARS in Iowa, they do say with their studies with cereal rye, I can't remember, I think it's either 6 bushel or 6% yield loss is what they've observed with their trials with cereal rye. So the university is also documenting it, and I think they have a number of different tillage systems there. But that's actually part of their science assessment of reducing nutrients, that they think that they'll actually have a yield hit, but they also just don't have data for other crops beyond really cereal rye, because the emphasis has been on being able to plant something late, tie up the nutrients for water quality, not as much all the other aspects in cover crops. And I think as we collect more data and we look at the models of testing and progression, like was started in the mid-Atlantic and moving in other areas, I think we will see the yield improvements as we move the right system in the right place for the right reason.
Okay. Got a lot of questions here. We're probably not going to get to all, but I'm going to see if I can get you.
With Iowa Soybean Association.
Okay. I'm going to see if I can get you a couple more questions. I'm going to combine a couple here because it has to do with mixes and really just a general question whether you're a proponent of mixes or whether you think it's just better to be simple with one. And then also along those lines, one of the folks here online asked if you've seen benefits from doing these larger mixes of like maybe even up to 10 to 12 species. Especially when it comes to trying to get a stand, I guess, and trying to avoid some of the winter kill issues that you might have with just a singular cover crop. What's your thoughts on the mixes and what they might do for you?
Okay. I really believe that the mixes are the way to go. I think when you're in the system, everything needs to be done in steps and moderation. And I think the biggest thing is you need to really plan what is it you're trying to achieve. If you talk to the people starting, and a lot of people are very concerned about having to do a spring termination. And so the number of things you would put in a fall mix guaranteed to be winter kill pretty minimal. And again, I'd call it almost like a training wheel system for people. And so probably the most popular mix that our company sells is an oats and radish mix, pretty much guaranteeing it'll winter kill in most areas. So I don't think putting in more species in that makes sense. But as you move to systems where you're comfortable terminating the spring, you want more growth, because in general, more biomass is where you get most of your benefits, more of the soil health improvements, more of all the different things, and partly spreading your risk. Some things that'll survive the winter better is part of it, but there's a lot of other synergies that go with mixtures. Some things that will grow fast. I mean, we put radishes in mixtures even for things that are in the spring because it's such a good fall scavenger. But in some areas, it'll actually break down and be released too early. So we have something else that'll continue to help hold those nutrients and not release them to better match with crop uptake. I think that's important. I think most people are not experienced enough to really understand why you would need a 10 or a 12-way mixture until they get more experience with a smaller number of things in there. But I do believe as time there'll be a lot more tailoring the right mixtures to the right area for what they're looking for very specifically. Are they trying to break a clay pan? Is it just a nutrient timing and a release issue? Is it a ground cover issue? All of those things will affect the mixture. So I think mixtures are the way to go, but I'd start off simple to begin with.
Okay. This question here kind of comes from you were talking about applying some nitrogen to your cover crop to give a boost with growth and that. And the writer here says that if you're applying 100 pounds of additional nitrogen to maybe recover about 25 pounds, is that actually counterproductive? They're wondering, are you actually losing perhaps 75 pounds with this strategy? And you can maybe give a good explanation of what you're trying to accomplish with what you were previously talking about.
Yep. No, I think that point is really good, and I would say, again, those were replicated plots, and I would not recommend people put 100 pounds of nitrogen out in the fall, especially if it's something they're planting in the 11th of September in this area. But that was simply done for several reasons. One, we wanted to make sure we were not limited in nitrogen at all, because we also picked a site we knew had been cropped down above average. So we wanted to see that difference and how it affected other nutrient uptake. But we also wanted to monitor how much of that nitrogen was lost. So if we had a high residual, we put that treatment in there so we could just see how much was lost. And we actually lost about 70% of the extra fertilizer we added. If you figure we did have some residual in others, by the end of the fall, we couldn't find it in the top 2 feet of the soil. So that's why we added as a loss. But I think the comment is right. We are not recommending you add large amounts of fertilizer in the fall. It is more you needed fertility to do that. And when I think in a lot of the environmental areas, when you apply phosphorus, you're applying nitrogen with it in the fall, and usually that's an ammonium form which can loss and convert quickly. And I think the cover crops can be a great match to help hold that nutrients. But I think if you're adding nitrogen for a cover crop, in most situations, I don't think you'd want to add more than 20 or 30 pounds.
Okay, wonderful. I'm just going to do one more question here quick, and it really has to do with, you were talking about some of the guys in the more northern climates, and obviously frost can come into play a little sooner for those folks. This individual is up kind of, I think, east of the Twin Cities, and mentioned that they chop corn for silage. But how long before frost do you need in order to benefit, from a cover crop like radishes or any other type of cover crop along that line? What's kind of your window of growth that you'd really like to have before it ends up being killed out?
Okay. It'll depend somewhat as do you have spring growth too or not. So let's assume that it's going to be something that's winter killed, like a radish. And it's important to remember that crops vary in terms of how winter hardy they are. And I don't mean just to survive the winter, but how cold it's got to be to terminate. So the radishes will go down to about terminate. So what we like to see, if you're going to get adequate growth just from the radishes, you really ought to have, at least 3, if not 4 days before your typical first frost. And so you'll get enough growth that you'll get some of the biomass production. And again, it depends on what you're after, but I think to get some ground cover, to hold a little bit of nutrients, That's typically what you're looking for fall terminated crops. Some are more sensitive than others, but that would be the simple rule of thumb I would use.
Is it true that with radishes,
Obviously, things like cereal rye. Oh,
I'm sorry, I'm sorry. Is it true with radishes that you tend to get down in the teens before you'll see them die out? Is that pretty accurate?
yep. Yes, you typically need 2 nights about 15 degrees or lower to kill them.
Okay.
And that's part of the thing too, is whether they're in a mixture and other things. That's one of the benefits of mixtures, is you have a lot more biomass covering over and protecting some of the more sensitive crops in there, so it can be even longer than that. But yes, they take 15 degrees, a couple nights of 15 degrees to truly terminate the tillage radish.
Okay. We're going to go ahead and wrap things up. There's a lot of other questions here, and Dr. Blackmer, if it's okay, we're gonna collect those and forward them to you, and allow you here offline to go ahead and provide some responses to those, and we'll make them available when we get the archive up on our website. And so I want to thank you for your time this morning, and really before we conclude, again. We're going to make this available via email to you, a replay of today's webinar, that is, just in the event you'd like to go back and review the entire presentation or parts of it. And you'll find that replay is going to go up on our No-Till Farmer website shortly as well. We've got a webinar archive section on the site where you can listen to other recently completed webinars as well. In that email that comes out to you, there's also going to be a few poll questions, real short and simple. If you'd take a moment to answer those, that'd be wonderful. It helps us evaluate the work we're doing with webinars here, and how we might do those better. And again, I mentioned we'll try and get as many of those other questions answered as possible for you. Hey, Dr. Blackmer, again, thank you for leading today's presentation, and I do want to also thank Cover Crop Solutions for sponsoring today's webinar. Also want to give thanks to producer Cole Vandermouse here for guiding us through all the technology. We hope that you're seeing some good progress with your crops right now, and we really look forward to having you join us for another webinar soon. So thanks for joining us, and have yourself a great rest of the day.